What is the future of containers? In this 3-part series, we are exploring the promising technologies aiming to make our cloud-native apps more secure without giving up performance. Previously, we learned all about microVMs, taking a deep dive on the most talked-about microVM, AWS Firecracker. This week on Mobycast, we finish looking at microVMs with a discussion of Kata Containers. Then we explore the world of Unikernels, which promise the same benefits as microVMs, but with a dramatically different approach. Oh, and somewhere along the way, Chris accidentally invents a new technology, conternels. Welcome to Mobycast, a show about the techniques and technologies used by the best cloud-native software teams. Each week, your hosts John Christensen and Chris Hickman pick a software concept and dive deep to figure it out.
Welcome, Chris. It's another episode of Mobycast.
Hey, John. It's good to be back.
Good to have you back. Here we are in a series on microVMs, which is super cool. And the second episode of the series, I think, was one of the best episodes of Mobycast that we've done in a long time. So we've got our work cut out for us today. Let's try not to be boring. And we're gonna continue
yourself,
on.
John.
What's that?
Speak for yourself. I'll hold my own. I'll be witty and entertaining.
So we're going to talk today, and we're not going to get into pleasantries and how the weather is there because I'm sure it's awful, and it is here too.
Snow.
Yeah, same here. So let's talk about software and computers. Mm-hmm. Yeah, and let's talk. So in part 3, we're going to talk about Kata Containers and Unikernels.
Yes, the infamous.
Just really wanted to say Unikernels.
Yeah, I mean, it might catch on, right? There's your meme right there. Go ahead, do it. You should do it.
Yes.
Post it to Twitter.
#Unikernels.
Yeah, there you go. So I mean, we're on this journey of just like looking at what's the future of containers. We talked about the problem, like the benefits, the pros and cons of VMs and containers. So VMs, strong isolation, high security. Containers, though, give us much better speed, performance, and efficiency of resources, but giving up some of that security and isolation. So how do we basically all the direction going forward now is like how do we kind of bring those two things together and resolve them? And 3 main things that we've been looking at. So we've been looking at microVMs and what they are. That's what we've talked about in the first 2 series of the first 2 episodes. Last episode, we really went deep on one of the most popular microVMs out there, which is Firecracker from AWS. And so today we're going to finish up talking about another one called Kata Containers. And then after that, we can move on to Unikernels, which is a whole, or Unikernels, which is a whole nother way of going about to get some of the same benefits. And then we'll maybe briefly just touch on like sandboxes container sandboxes as like a third kind of prong out there, although probably much less interesting for us.
Right.
So yeah.
But is any of this interesting to anybody? Like, what's the point? Why are we even talking about all of this?
Yeah. So it's interesting in the aspect of like this is the evolution of technology, and a big part of it, it's just all being driven by cloud computing, which is really kind of interesting. And not only that, it's actually everything we're talking about is going to be really important for devices as well. So IoT. Right, because they have some of the same constraints where it's like you're very, very special purpose, but you really have to take advantage. You need either speed or you need really great resource efficiency, right? So that sensor in your home, right? Like it can't require 8 gigs of RAM or a huge CPU, right? So it needs to be very, very resource efficient.
And another thing, I'm not sure if microVMs will have the same kind of trajectory that Docker did. I kind of think that they won't, and that they'll be mostly behind the scenes stuff, and that once you get your head around working in a containerized workflow, that will continue to be what you need to know into the future as microVMs become more popular. But I say that with a caveat because I distinctly remember somebody saying, "Oh yeah," and like this is like 10 years ago now. Somebody being like, "Yeah, Docker That seems kind of cool, but it's only like script kiddies talking about it. And so it's pretty uninteresting to me. And that guy's probably writing Docker up and stuff like that every day as part of his job and being like, I was kind of immature in my reasoning about what Docker was all about back then. Mm-hmm. So, maybe it's not quite the same with microVMs. Maybe they do sort of stay in the background and they're the domain of people that work inside big cloud companies and stuff like that. But they are, along that same trajectory. So if you were pushing Docker 10 years ago and you're pushing microVMs today, then, you're going to probably your job is probably going to involve doing something with microVMs like 9 to 5 every single day of the week in 10 years.
Mm-hmm. Yeah. I mean, here's the way I look at it. So, we said that there's these three kind of main prongs, and with microVMs, unikernels, and sandboxes. So let's just forget about sandboxes, because sandboxes is just really how do we take standard containers and give them some stronger isolation by sandboxing the kernel, right? So so Google gvisor project is doing that, but it's not really dramatically different, and there's not a lot of interest there, right? Because it's really only addressing the security part of it. It doesn't give us any other improvements it actually slows down containers, right? Because you're going through a proxy now. But so let's talk about microVMs and unikernels. And it really is, the way you can look at it is that microVMs slot in to the abstractions that we have right now with containers, right? It just becomes part of the container infrastructure that we use to run them, but it doesn't change how we're still going to use containers, and we still use all that rich ecosystem of tooling. So think of microVMs as basically a drop-in replacement for run C. And so how much do you, everyone that's using containers now, how many of them really know do they, one, even know that run C exists? And two, what does it do? You just don't need to know too much about that, right? It's the guts of it, the implementation of the infrastructure. It's just not too terribly important. And I kind of see that's where microVM slotting in versus unikernels, which we're going to talk to much more in depth. They represent this radical shift in how we build our applications. And that is more analogous to back in, going back 10 years when containers came online, right? It was this huge shift of going from I'm building an application that's running on a VM to I'm now building an application that runs inside a container. And we've talked about this quite a bit on previous episodes of Mobycast, where it's just that is a huge mental shift. It's a huge culture shift. It's a process, and it's taken a long time, right, for that to get that traction. And it does. There is that pushback from folks when they make that change. So you're going to have that same kind of adoption problem with unikernels.
Right.
But not with microVMs. microVMs just slot right in and people won't even have to know about it. But I guarantee you going forward, the odds that you'll be running your containers, one container per VM in a microVM, is extremely high. If you're running in the cloud, that is going to be the pattern. But it's just going to be, infrastructure, undifferentiated heavy lifting that for the most part we're not going to need to know about. But it is important for us to know at least what that is and what gains we get from it, and be able to talk intelligently about I know what a microVM is.
Cool. All right. So let's jump in. Are we going to go straight to Kata containers?
I think so. So, we've kind of set the groundwork. I think we know where we're at. We're talking through microVMs. Like I said, we spent a lot of time going into Firecracker, and we finished up with that last time. Now let's just look at another one real quick with Kata containers, because that's another popular implementation that's out there that folks may have heard about.
Right. And we even did a spoiler alert at the end of the last episode, so people already know what you're going to say.
Yeah. And there's really, there's not as much to say about this, because unlike Firecracker, which is a hypervisor, Kata containers is up the stack a bit. It's not a hypervisor itself. It is really more like that run C replacement.
Okay.
So it's more at the container run. So it's that portion of the container runtime that says, instead of the services above me think they're asking of me to create a container, But instead, what it's doing is it's first creating a VM, and then it's creating the container inside that VM. So just like Firecracker Container D is doing that for Firecracker VMs, Kata Containers is doing that for other types of VMs. And so Kata Containers works with other hypervisors out there. So it does work with things like QEMU, KVM, and it also there's been work to integrate in with Firecracker as well. So think of this as more of like at the container runtime integration point in the infrastructure.
Well, I guess what I'd like to know then, if it's creating a VM and then running a container inside it, maybe you just answered that, and I'm not quite familiar enough with, I can't remember exactly what KVM and QEMU do. I think they're just different hypervisor implementations.
So yeah, together there are a hypervisor. So KVM is the Linux kernel virtual machine module, right? And so that is a way of making the Linux kernel a hypervisor. There's two parts to it. There's the kernel component, and then there's the user space component. And the user space component is responsible for emulating a lot of the devices and some of the other emulation capabilities. QEMU is that user space component that does the emulation. So you'll see something like KVM is paired up with something else. So if you'd be KVM and QEMU is your hypervisor, or like in the Firecracker space, it's KVM plus Firecracker. Firecracker is that alternative to QEMU.
So there we go. It totally answers my question, because I was like, well, if Kata Containers is making VMs to run containers in, what VMs is it making? And it sounds like it's either making, like they're going to do a Firecracker one, so that'll be a super, it'll actually be a microVM, like super lightweight with a bunch of stuff removed from it. Or it'll be a QEMU one, which is like a full up Linux kernel that does everything. Yeah,
just keep in mind, like that QEMU, when it's configured to use that as the hypervisor, I mean, that's still really lightweight.
Okay.
Right. So it's as much or as little as you want, I think, of the emulation. So they're very, very fast. So if you go to like the QEMU project page, you'll see it's like, wow, like if you use, like we are designed to be very high performance, and we can, you can spin up these VMs very, very quickly with this as the hypervisor. So it's by no means like this full up heavyweight, long boot time alternative. So it's very viable to have Kata Containers and have all the benefits of Kata Containers, but using QEMU as your hypervisor as opposed to, say, like Firecracker.
Okay, cool.
You're still going to get great performance gains, right? You're still going to be extremely, fast and really great with resource efficiency. It's again, the difference there is that, like Firecracker, it has its own basically user space component for the emulation, and it's just purpose built for AWS land and the kind of use cases that it has, versus QEMU is a little bit broader.
Okay.
Right.
Super. That's exactly what I needed to know. Thank you.
Cool. Yeah. And so maybe it's kind of some things with Kata Containers that are maybe important. It's just from a project history standpoint. Kata is the result of a merger between two projects. So one was the Clear Containers project from Intel. And with that project, they were focused on very fast boot times and enhanced security for containers. So they were looking at less than 100 millisecond boot time and enhanced security. And so that was Clear Containers from Intel. And then the other project is it's from Hyper, the Run V project. And it was a hypervisor-based runtime for OCI. So remember, OCI is that container runtime interface that we use for our containers that allow, like Docker was one of the folks behind that to define like what is that common protocol like that we can expect from the container runtime, and be able to slot in different types of runtimes into our system, not just container D and run C and whatnot.
And that protocol, just to kind of bring that conversation back to life for some people, what would a protocol even do? Well, containers need to be stopped. They need to be started. They need to be identified, a few other things.
Yeah, exactly. So really, the Hyper Run V project was pretty similar to like again, like what Kata is. So it's that OCI compliant piece of the stack for sliding in and saying, I'm creating VMs instead of creating VMs with containers inside those VMs as opposed to just creating containers purely. And then the Clear Containers project was bringing some of the performance and security gains that they were implementing with containers. So those two things merged together, I think, near the end of 2017 and became the Kata Containers project.
Okay. It's
still relatively newish, right? So
they're still working on merge conflict resolution.
I think they're beyond that.
Okay,
but it's really like, this is it's less than 2 years old. Kata Containers as a thing, right? Which is in the technology world, like that is still pretty early on, pretty early days, and so they still have a lot of work ahead of them. They do. There has been work to integrate them with other systems. So in particular, in the Kubernetes side of the world, with the Kubernetes runtime specification, the CRI-O. And if anyone knows if there's a way that folks out there pronounce that, like if it's cryo or something like that, I would love to know. But I will just spell it out for now. So that is the runtime spec for Kubernetes. And so Kata is one of those things that you can now slot in. So Kata is now an alternative to run C for the container runtime in Kubernetes.
Cool.
So that's one way you can use Kata containers today with Kubernetes.
So it seems like there's a death match happening a little bit between Firecracker and Kata, and the advantage that Kata has is that it's already they started from a point of view of like, well, let's make sure that this is generally useful. And Firecracker started from the point of view of like, let's make sure this solves AWS problems very, very well. And so once Firecracker was open source, people are like, well, how can we make this more generally useful? And so that's the direction it's going. And Kata is like, I guess like if you're in AWS, like maybe just use Firecracker because it's already really well built for that environment. But outside of AWS, maybe Kata feels like the better choice.
Yeah, here's the other way to look at it is just it's not a death match between Kata and Firecracker. It's a death match between Kata and Firecracker Container D.
Yes.
Right?
Yes.
Because Kata, you can use Firecracker VMs with Kata, but you wouldn't use Firecracker Container D, right? So that's what's going head to head here is Kata versus Firecracker Container D.
Well, and then so Kata is like a couple years old and Firecracker Container D. How old is that even? Like 6 months old?
Yeah, so Kata is definitely further along in that space. Right?
Interesting.
So it may be like, hey, if you do want to use Firecracker VMs with Kubernetes, then we talked about last episode how Weave has Ignite, which is basically it slots in like Kata containers would, right? It's another runtime. So it's kind of interesting to see like this explosion now of runtimes, and it'll be interesting to see like, is there, even more of these projects out there that happen? Because for a while it was really just basically container D and run C. But now, Docker's kind of like, what's going to happen there, right?
Right.
So we'll see where this goes. But I think if you are running Kubernetes, then you're probably looking at things like Kata or Ignite to run Firecracker VMs.
Cool.
Yeah. So that's Kata. So again, think of it as a alternative to Firecracker Container D, and again, it's something it's been out there. It's been used in production. It started off like Clear Containers was used at scale in production by companies like JD.com, which is like the big e-commerce, big Chinese e-commerce company. Kata Containers are being run in production by Baidu, another big Chinese internet company. So it's there. It's established. It's being used in production workloads, and again, probably just further along than some of these other projects that we've talked about. Right.
It's kind of funny though, like, we say that, this container runtime is being used in big production workloads. And while there is some amount of stability that you need and some amount of operational capability that you need to do that, the whole point is that these like containers are kind of throwaway. So even if they're like, total chaos inside that system, it doesn't really matter as long as there's enough of them running to handle your traffic. So, you know what I mean? Like the irony is maybe all this stuff doesn't need to be as mature as it once did.
Yeah. I mean, it has to be mature enough though, right? So it's like, there is a big difference between like 80% like correct versus like 97% correct, right? So you might be able to run production 97% correct, but 80% is just too many crashes, right? And it's just not going to work. Yeah. So there is that.
Yeah.
Yeah. So I think we can safely assume that things like Clear and Kata are at that 99% or higher level. Pretty tried and true.
Cool.
Yeah. So I think we can kind of wrap up microVMs with that. All those techniques are basically just like, we're going to run our containers inside a VM, and that's going to give us get us back that great security and workload isolation capabilities that we had with VMs, but we still retain the performance, the efficiency, the resource efficiency, and more importantly, like that abstraction, the tooling, and the ecosystem of just, we still get to work with containers with really not even having to know the details of like, it's now my container is inside its own custom bespoke VM. So let's move on to the next technique, which is unikernels.
Yes,
and this is totally different. It is. There's not a lot of they really are unicorns. I mean, I don't think there's not a lot of unikernels out there in practice, and we'll get into this, and we talked about this earlier in this episode, where they do represent like a fundamental shift in how you go about using this tech, and how do you package your application as a unikernel. Completely different than containers. It's a completely different approach. It requires totally different tooling. Some of them require totally different languages, programming languages. So this is a big change. So let's just recap, like, what are they? So basically what they are a lightweight, immutable operating system that's been compiled specifically to run a single application. So what does that mean? So, normally on a system, you have an operating system, and it's designed to be, multitasking, multi-threaded. It's got all the support that an operating system would have, managing kernel versus user space, interrupts, just devices, I/O, storage, all that kind of stuff. So with unikernels, what you're doing is you're saying, I have this single application, this single process that I want to run. I want to, instead of running a full-blown operating system, I only want the pieces of the operating system that I need to run that single process. And I'm going to go and compile basically an executable, pulling in just that very specific code that I need. And the output is, instead of now running an operating system on my server with my application running, instead it's just this executable that has only the bare minimum amount of code that it needs. And so it's just a single process, single application running on that machine inside that unikernel.
Right. I think when I hear this description, it just feels like everything that was old becomes new again.
Absolutely.
Yeah.
Right? This is kind of, how it all, it really goes back. This is, we're going back to...
goes back to like the pre-operating system days, like way back.
Yeah. Mm-hmm. Yeah, before operating systems became multitasking, right? I think we talked about this last episode or the previous one about, giving an example of the early versions of Windows, like Windows 3.1, where it didn't make a distinction between kernel, protected kernel, and user space, and how an application, when it crashed, it could possibly take down the kernel, which means you have to reboot your machine. And then they, said, no, we're going to build this in a more secure way, and we're going to isolate that so that rogue apps or poorly behaving apps can't take down a whole system. And so this is getting rid of all those protections, right? So there is no difference now between kernel and user space. You don't need one because there is no kernel anymore, and a differentiation between the kernel and user space. There's just one, and that's just your application.
But even further back than that, like, I think before there were even operating systems, it was sort of like this whole, like, well, how can I just get a piece of silicon to run an application? And I just want to kind of bootstrap this application into existence. Like, when you turn on this machine, this is the application that's running.
Yeah, sure. I mean, I pretty sure, like, that's, I mean, if you go back to the name escapes me right now, but what's kind of credited as the first PC, the one that Bill Gates and Paul Allen saw on the cover of Popular Electronics. In that particular one, they had to load their program in, right, as part of like turning on the machine, and that's it. So you turned it on, and it would go run and just run through the program,
right?
And then we evolved from there.
Right.
Yeah. So this is kind of exactly that, right? But it really is being driven by the exact same use cases that we see with microVMs, right? So it's very special purpose. We're using unikernels for things like cloud applications, that need to be very, very fast. They're very special purpose. They really are kind of doing one thing and one thing only, and they need to be very resource efficient. Or it's something like an IoT application where you're in a device, and again, same kind of constraints. So unikernels are good for the exact same things that microVMs are, right? Targeting those environments.
Right. I guess the one thing that I want to think that this makes me think about that is worth pointing out is, like, with a unikernel, you're still probably running code that's generally kind of generalized. Like, the code doesn't exactly, like, you kind of need all of the instruction set of like a processor, like a general purpose processor. So it needs to be able to, do everything that a general purpose processor can do, as opposed to some of the things we've talked about before, where, like, it's so specific that you can drop it down and like put the code into silicon. And the example of that, like, just turning an app into actual silicon, like putting it on a chip. Like you see what I mean? There's like a difference between these two things. Like, I guess maybe if you're going down the unikernel path, like if you're like, well, I'm going to build a unikernel for this because we need to run it on 100,000 machines. Perhaps if you're like, actually, we need to run it on 100 million machines, you might be like, let's take our unikernel and figure out how to, codify it into a chip so that we just have an ASIC for doing what these unikernels we had before are doing. Yeah. Like that seems like that.
It's really easy just to go and throw this into a ROM, right? So, you could literally, if that's what you wanted to do, right? This could be pure hardware, with the unikernel stored in ROM or something like that, or PRAM. So, it's very, very minimal. It's very, very tight. And it's very, very specialized. So
I guess without knowing exactly where that line is and when you do it and how those trade-offs work, because that's not really our job and our expertise here at Mobycast, we can at least identify that gradient, right? Like, all the way down becomes silicon, becomes ROM, becomes chip stuff, and all the way up becomes, like running software on actual machines, like any kind of software on machines, like sort of custom as needed bespoke software. Right. Do you see that gradient? Yeah. Am I speaking gibberish here?
No, so I think we'll kind of get into this too, right? Where it's just, maybe just jumping to the conclusion a little bit. I'd say that, like, microVMs and containers is really how we're going to be interacting with this stuff. Unikernels are really interesting, and it's important to talk about them because they're really aiming at some of the same problems that microVMs are addressing. But they're just, like, there's the adoption, the people that are going to use unikernels are going to be a much smaller set, right? It's really very specific things. So like if you are a big cloud company, and like you just need to run just a bunch of web servers, like you may turn your web server into a unikernel, and just employ the effort to do that, because it just makes sense to you're going to overcome the investment that goes into to doing that, and the learning curve, and like it's hard. That's the other one of the things that's kind of hard with unikernels is like you have to like recompile with whenever there's a device driver change, right? So versus like with VMs, they abstract that away from you. So that's one of the benefits of something like using like Kata doesn't have to worry about that. Like it's the hypervisor is responsible for having to deal with devices. It just has to deal with the virtualized device, right? So I don't know, is that kind of what you were getting at with the gradient?
Yeah, it is it is that. And essentially I think the key driver on the gradient is essentially how many of these things are we dealing with, and how important is efficiency. So the more we're dealing with and the more important efficiency is, the more you get down into unikernels, and then even beyond that, all the way to putting things into silicon. And the less of them we're dealing with and the less important efficiency is, the more likely you are to just type in a command to run the program for yourself so you can just use it. Like that's a single instance of a program.
Yeah. And I think by and large, almost all of us, like 99.99% of us, we're going to be in the container microVM world. And it's a very, very small fraction where unikernels make a lot of sense. And it's worth going through the effort to use them.
Right. We cover a lot of information here on Mobycast, and if you've ever wanted to go back and remind yourself of something we talked about in a previous episode, it can be hard to search through our website and transcripts to find exactly what you're looking for. Well, now it's a lot easier. All you have to do is go to mobycast.fm/show-notes and sign up. We'll send you our weekly, super detailed outline that we use to actually record the show. A lot of times, this outline contains more information than we get to during our hour on the air. So sign up and get weekly Mobycast cheat sheets to all of our episodes delivered right to your inbox.
Like if you're working for a company where you're planning to, have a bunch of IoT devices that, have a very, just basically just running a single application for, capturing data and then sending it on or something like that. And that you should be looking at unikernels, right? As just one of the possibilities there. If you are, maybe you're on-prem and you have a very large data center and you have a really core application that's serving a lot of requests, that may very well be a candidate. Say, we're going to turn that into a unikernel, but it's still going to be like you may, in that particular case, you could have an application landscape. Maybe there's 1,000 applications that you have that your engineering team and IT department are deploying. Well, maybe only a handful of those really qualify as like being worthy of being unikernels, and the rest should still be containers.
Right. I guess I want to point out, though, that tooling matters. And if a lot of people put in a bunch of hard work around unikernel tooling, and the next thing we know, there's like a drop down in Visual Studio that says compile as unikernel, and that's all you have to do. Like, oh, well, then maybe we all start using them, right? Like compile as unikernel and deploy to Azure right now. Click.
Yeah, I mean and that's what's missing, right? So with unikernel, so one, like, you are giving up some flexibility there, right? It has to be a single process, and that may or may not be a deal breaker for your particular application. But if it's not, and if the tooling is there, right, so that it's just as easy to create a unikernel as it is to create a container, then absolutely. Like, I mean, it's gonna, but it's just, I just don't see that happening anytime soon. Like the unikernel ecosystem,
you're on tape saying that.
Absolutely, and I will totally do that. Like, anyone wants to throw down the bet, I will. Go do a survey of the unikernel ecosystem, and it is so fragmented. It is so fits and starts. There's some interesting projects out there, but
Would you say that it's just for script kiddies? I'm just writing this down. Just for script kiddies?
I think it's for folks that are just really love geeking out on hardware and working on hard problems and dealing with like kernel level type code, right? So there've been like 10 or more projects out there that are dealing with unikernels. One of the ones that seems to getting a lot of traction right now is OSV.
Okay. Which
is kind of really designed for Linux apps in the cloud. And another one that's been around for quite some time is Mirage OS. And there's other ones like Include OS, there's Rump and the Rump kernel. But there was one called Runtime JS. A lot of these, they were kind of started, 4, 5, 6, 7 years ago, and they had some, a burst of a flurry of activity, and then they've kind of died off. So like Runtime JS was basically for JavaScript applications. You can write a JavaScript application, Node application, and have it run as a unikernel. Well, it looks like that project basically kind of like shriveled up about 3 years ago.
Okay.
And Mirage OS, it looks like a lot of the activity has kind of trailed off in the last couple of years as well. Mirage OS also requires you to write your application in OCaml. So, I mean, so that's a really big change, right? Like
right,
to say,
yeah.
We're now going to have to go learn this new language, and it's not even like, it's not like even like Rust or Python. I mean, it's OCaml.
Yeah.
So
join us at the OCaml meetup on Thursday, where Jerry talks about how he's incorporated making unikernels into his dev process.
I know. It's like, wow, instead of 3 people, there's 4 people tonight. This is amazing. Let's go attack the new guy. He's like, oh, I thought I was here for the Rust meetup. Yeah. No. So it's just.
But seriously though, there were people having the same conversation about Docker 10 years ago and saying, well, it's just for people that like playing around with C groups.
Right. But here's the difference though. Unikernels have been around this community has been there for 5+ years. So Docker
didn't we also do an episode where we talked about how containers have been around for 20 years or something like that, or like a really long time?
Until the tooling came about. Yes. So
okay. That's the only point I'm trying to make. If it turns out that they're wildly beneficial once some certain tooling comes around, then everybody's going to jump on, because that's what we do as developers. Like, we love the new and the next generation that's tired of hearing graybeards talk about containers and how I was there when blah blah blah. It's going to be like, where's our thing? And it could be unikernels. Who knows?
Yeah, I think unikernels are just so specialized. It is going to limit. It's going to limit the use cases that you can use them for. So I think if the right tooling comes along, they could become much more popular than they are right now. But again, it's not going to be general purpose. And it's that big shift change, right? It's really similar to like what it took when we went from building for VMs versus building for containers, to go to this idea of like, I'm no longer in an operating system. I'm single address space, single process. Like it's just a really just radically different way of building an application. And
but listening to you say that sounds so cool. Oh, that's cool. I want to do that.
Yeah. There's nothing. So, okay, maybe we should talk. So we talked, okay, there are, many projects out there that are in this unikernel space. Really, OSV, I think right now is the one that has the most momentum. It's also interesting to note that Firecracker, the only guest other than Linux that it supports is OSV. So that gives some credence to the OSV project for sure. So you can write you can have your unikernel done in OSV, and then you can now run it inside a Firecracker VM. And that is supported today.
I want to know, I want to get my head around what OSV, how to think about it. Because I can kind of think about a unikernel, and I can kind of think about, well, somehow you have to say, kind of statically link your code to the kernel, right? Like that's essentially what you have to do.
Yeah.
And I want to just kind of picture what OSV does or what it is that enables me to do that.
I think you can really just think of it as it's a compiler, and so it is running. It requires a hypervisor, right? Because they don't want to go and try to have support for all the different device drivers and everything else, right? So it requires a hypervisor. So it's going to be it's going against that virtualized model. So it doesn't have to worry about that. I can let the hypervisor worry about device drivers and whatnot. But you're just basically it is a compiler, right? So you are you have your application. You're now going to run it through a compiler. That's going to spit out basically an executable in image format, and it's basically going to create a VM image, right? But it's just no longer this full-blown operating system. It's not. You can't. There's no fork command, right? You can't spawn off a new process or anything like that. It's just been statically linked, all the code that it does need. It ends up being these unikernels. They implement. They say that they focus on the protocol implementations rather than device drivers, and that really just means they are writing the support for. Those are the OS libraries that they need in order to give the support that the program thinks, and so that it's as if it were running on a full-blown operating system, but instead just pulling it in. So all these just think it's a compiler, and it's building a VM image. This is really how to look at it.
And then the name it's like with all of these projects, the name kind of gets to applied to everything. So you go and you get the OSV toolkit, and that's the compiler that you're actually downloading probably. And then you run probably there's a CLI, I bet, that's like, OSV build or something. Who knows what it is? And then you point it at your directory and it builds it. And then out comes an image that you just mentioned. And then in the part where you said Firecracker has support for OSV, what that means is that image, you would call it an OSV image, and when it's actually instantiated and run, then you would call that an OSV unikernel. So everything kind of gets that name OSV on it, even though it's different things. Like there's the OSV compiler, the OSV image, and the OSV actual running unikernel.
Yeah, cool. Like when you tell Firecracker, hey, I want to create up a VM, you basically are telling there's command line, there's API, command line flags that tell it, do you want to use a Linux OS or do you want to use OSV? And if OSV, here's a path to my image, right, to go use.
Well, that sounds fun. I want to go do that right now.
Well, I mean, you can. So, I mean, we'll have there'll be links in the show notes to go see all these different project pages, and they all have tutorials. And if you want to go write some OCaml, you can. Mirage OS will show you how to do that.
That I don't want to do.
If you want to go create something with OSV, and you can go download Firecracker yourself and OSV yourself, and go build all this stuff and play around with it. The other thing to point, so just on the tooling landscape here, there is a kind of a newish tool out there it's pronounced Unique. It's spelled out.
Oh, I totally just read that as Unix.
Yeah,
I didn't even notice that was a K.
Yeah. So it's spelled out. It looks like uni and then capital K, but apparently it's pronounced Unique.
And it looks like the word Unix.
Yes.
So bad job naming people, whoever did that. Try harder next time.
Yes. And so what this is trying to be some of that Docker-like tooling for making unikernels. And so what it does is it supports building unikernels for Mirage OS, for Include OS, for OSV, and for Rump. And so for each one of those, though, it's got to be in specific languages, right? So if you want to make the Mirage OS unikernel, then it's going to be OCaml that you need to write your application in. If it's Include OS, it's C++ code. OSV supports Java, Node, C, and C++. Rump is Python, Node, and Go. And then for Firecracker, it needs to be Go. So if you write your application in Go, then you can use Unique to now compile that into a Firecracker VM.
Cool.
So that the Unique, it's open source. It's from the Solo.io team, and we've talked about them in the past with things like microservices observability. They have a whole suite of open sourced software for dealing with just cloud development. So they have things like Glue, and there's some tools around observability. Lots of really low-level technical, interesting stuff they're doing. I think I've mentioned this in the past. I felt a little bamboozled at some of these conferences where I go to a talk that sounds really cool and ends up being a demo of one of these solo projects. As opposed to being more general purpose, right? And it kind of feels like it's an ad for it. But all that said,
yeah, which is tough because it's like it's an open source project, right? So is it an ad or is it not?
Yeah. But anyhow, so Unique is out there, and it's kind of that's its goal, right? Is to kind of be that Docker-like tooling for Unikernels. So something else.
They were listening. Those folks were listening to Mobycast, and when I was saying I think this is all going this direction, they were like, "Yeah, he's right." And when you were saying it's not, they were like, "No, he's wrong."
I will gladly have a smackdown with them, and it'll be friendly, right? But I'll still stick to my guns, and I think we can all I think we'll all come to a point where we can agree. It's not a death match between containers and Unikernels, that they each are going to have their place, and it's just containers by far. Conternels. There we go.
That's what's coming
next. That's the future. Conternels. Yes. TM. I'm trademarking that right now. I'm going to go get that domain name.
I love that. Oh, so fun.
Oh, you bet. So there's room for both, but by and large, containers will have the majority of the market share, and Unikernels will be relegated to a small, specialized, but important part of that.
Cool. We have a couple minutes left, Chris, and I just wanted to. Are we done with the outline for today?
I think we are. So we went through in depth with microVMs. We've now really, I think, understand Unikernels and its landscape, and we talked about sandboxes and really quick sandboxes. It's really Google, the gvisor project there. Is kind of taking that approach where we've talked about containers. One of the security problems that they have is that it's got a shared kernel across all containers, including with the host. And so what that project is doing is it's creating a kernel proxy for every container. And they're actually implementing the syscalls for the Linux kernel in the code for that proxy. And that way, instead of having just a single kernel for the entire system, now each container has its own kernel. But so that becomes the isolation. So it's not a VM, right? And that really strong isolation, but it's just this. It is tighter, and it's more locked down because each one, they're no longer sharing a kernel.
Right. I don't know if it does seem like it's like, well, if you're not taking advantage of the hardware capabilities of the chip that lets you do virtualization, then can you really trust that software to really break it down and isolate it? Anyway, maybe it'll be interesting to see where that goes.
Yeah.
And working on the isolation problem from the container side instead of working on the speed problem from the VM side, it does seem like a worthwhile thing for some people to throw their minds at, for sure.
Mm-hmm. Yeah.
Just because we had a couple more minutes here, I wanted to get your thoughts on something just completely off the cuff. I think I sent you a article the other day, or just a link to Oxide Computing. That's Jess Frazel's new company. Did you see that? Are you aware of them?
Mm-hmm.
Yeah, I just thought it'd be kind of fun to talk about it for 5 minutes. It's interesting because, we're saying all the innovation is happening inside the clouds. And we're even talking about that exact innovation in these past 3 episodes, right? But we've also talked about we also talked about it in our reInvent post shows, like, moving hypervisor into Silicon and moving some of the networking and changing the way the networking protocols work. And so basically this, Jess and her partners are making a bet that they can give people that want to operate on-prem some of the advances that have happened in actual server, in servers. Like, and so I don't know. Do you think they can? Do you think that they're going to, like, are you interested in seeing what they do with that?
So, yeah, I mean, so I guess, so the caveat is I'm not an expert in the on-prem market space, right? So
sure,
I don't.
Sure. Me neither.
So so what we do know, right, is like we've seen numbers where it's like, 3% of the compute workload is in the cloud and 97% is not.
Right.
So, okay, that sounds like, quite a bit, but it's like, I don't know, is that like, are we talking about like folks where they have a single rack of computers makes up the bulk of that? Or is it like people with like full blown data centers with 20,000 servers in it, right? So it really kind of boils down to like, what's the market space for this? I mean, are there enough folks out there that really have the need for this? Like, that's one of the reasons why cloud is driving the innovations, because they have a very real business need. So, Google and Facebook started off kind of leading the way with this just because they had to, right? Like Google was like, we have to have millions of computers, so we're going to start building our own, and we're going to build it based upon like a blade type architecture, and then just keep going from there. So we just need to have hardware folks on the team and continually doing that, just because that's the only way that we're going to be able to scale.
Yeah.
And Facebook had the exact same problem. And
right.
So, and then obviously public clouds like AWS and now Google Cloud and Azure, I mean, they all have the same problems also. So it makes a lot of sense. I'm not familiar enough with just like the customers in the market space for on-prem. Like, is this a compelling enough solution for them? Do they really have that problem, or are they okay buying blade servers or one-use servers from folks like Dell or whoever else they're getting their compute? I've been so removed from that on-prem space, thankfully, for so long, right? Like, it's
right.
Like, I can't imagine going and building out my own data center now.
Right.
So
you kind of can like get a sense of it though, right? Like you kind of can feel like that there must be, like, it just feels like when you go to conferences and you see the kind of companies that might sell that kind of stuff, it's like, oh yeah, that doesn't look new-ish at all. And I can kind of imagine that maybe a reason for building this company, this Oxide computer, is like, because the blade server sales companies are like, yeah, we're on version 5.8, and with 5.8, we've added this faster processor that we bought from Intel, and we just put it in there, right? And like, they're just kind of like adding more and more of like whatever the commercially available hardware is. But then inside the clouds, they're like, yeah, and we're buying these machines, we're ripping them open, we're changing out all these components, we're making them our own, or we're even manufacturing them ourselves or whatever. So it does feel like there's probably a pretty substantial difference between what's inside the box on a computer sitting inside an AWS data center or a Google data center versus what's inside the box on a computer running like a proprietary healthcare company data center.
Mm-hmm. Absolutely. I mean, and that's totally true, right? Again, it's just, is there need for having that AWS level specialization in on-prem? Are people willing to pay for it? And then not only pay for that, but are they willing to like take the chance, right? Like this is like really
for sure. I mean, that's the big one.
This is really important stuff, right? Versus like to say, I'm going to bet it on like this brand new thing coming out of a startup. This is the meat and potatoes. So there's that. I'll go out on a limb prediction. They're acquired within 18 months, 2 years, and by a hardware company. Yeah. And then, that makes sense because then a no-brainer.
Yeah, because they would be, they'll probably be successful at making a pretty cool machine. And then if they can make that, they'll have a hard time selling it because of the problem you just said. but then somebody will look at it and go, oh, I want that. Like, we can just pull that in-house, and then they have all the sales relationships and everything that they need to make it go. Yeah.
I think, it just makes a lot of sense to be like, this is core technology that can really benefit one of the bigger companies that's selling hardware. And
cool.
It'll be a no-brainer. And, they have a great team, a great founding team. So, Brian Cantrell, being there as one of the three founders, like that's, he's got a long time at Joyent, as being one of their primary leaders there. And I mean, he was, one of the key stewards of Node.js, while during those formative years and whatnot. And I think before that he was at Sun. And so like really, really strong pedigree in that space.
Mm-hmm. Super cool. Yeah. And it's a fun company to watch just because, I mean, it's literally like you get to think about Halt and Catch Fire, like that TV show, and just like the starting a computer company. Wow. Like here we are, 2020, and somebody's starting a computer company. How fun.
Yeah.
So, very cool. Let's talk again next week. I'm not sure what we're going to talk about. Do you know?
Who knows? There's it's going to be a surprise.
Okay. Let's surprise everybody.
Okay.
All right. Thanks so much for this episode, Chris.
Thanks, John. Talk to you later.
Talk to you next week.
Bye.
Bye.
Thanks for being aboard with us on this week's episode of Mobycast. Also, thanks to our producer, Roy England, and I'm our announcer, Stevie Rose. Come talk to us on mobycast.fm or on Reddit at r/Mobycast.